recorded live.
Hello and welcome to the Virtualization Security Roundtable podcast, episode number 67. We have been doing this now for well over a year, actually closer to 2 years. And I thank you everybody for joining us through that period, and we expect many more. So our panelists today are Eben Rodriguez, who consults with enterprises to assist them to secure and operate their virtual environments. Michael Berman, who is the CTO of Catbird, the pioneer and industry leader in security and compliance for the virtual environment. Myself, Edward Holetke, a.k.a. TechSciWill on the VMware Communities Forum, and author of the book VMware vSphere and Virtual Infrastructure Security, Securing the Virtual Environment, which is available on Amazon, as well as my VMware ESX and ESXi in the Enterprise Second Edition book. Podcasts are equalized by Tim Pearson, contributing author to the security book and owner of Data Century, Inc. Our special guest panelist this week is Greg Farrell, a network and security architect for a big bank somewhere in the world, and blogger at etherealmind.com. Well, Greg, today's topic is really about a new technology that came out from Cisco that was rumored 6 months ago, and that was the VMFX, or the VM Fabric Extender.
Mm-hmm. Yeah.
Brad let us in on a little secret about that a while back, but you say you've decided to use it. Why don't you explain what VMFX is, why you'd used it? Take about 5 minutes, and we can start opening the discussion to the other panelists.
Okay, I'll give it a go, but describing FEX without a whiteboard is going to be quite challenging, and if you hear my arms waving around furiously, you'll understand that I'm drawing on a virtual whiteboard. And
okay, that works.
So the thing about a fabric extender, so FEX is actually short for fabric extender, and VM stands for virtual machine. So fairly obviously, it's it looks like a NIC. So it's physically a NIC that goes inside the UCS chassis, but unlike a NIC, like other UCS NICs, it's actually got a processor on board. So it has all the hardware acceleration and all that happy goodness that you've got. But that's about where the similarity ends. Now, to understand the fabric extension concept is kind of difficult to explain, but I'm going to give it a go from here. Inside of the switch, the upstream switch that the FEX connects to, in this case for the UCS, it's the FI, Fabric Interconnect, or the UCS 6100 switch. And in there is a thing called a fabric. We use the word fabric a lot. Fabric really comes down to a silicon switching engine, which is the switching fabric. And the silicon switching engine has a bunch of inputs and a bunch of outputs. And those inputs then extend to each interface on the UCS 6100. Now, what we do with the 6100 when we connect it down to the FEX card in the UCS chassis is, instead of actually bonding the ports together, so let's say we connect, and in a hypothetical situation, 4 by 10 gigabit ports from the FI down to a single UCS chassis. In a data network, we would normally bond those 4 10 gigabit ports into a 40 gigabit per second LACP bundle to form one 40 gig pipe, albeit with a speed of 10 gigs, but the overall bandwidth would be 40 gigs. In a UCS chassis, when you enable the FEX mode, what you actually start to do is you actually pin that IBM, that channel. So instead of bonding them together, each of those 4 by 10 gigs remains an individual 10 gig channel. And each of those 10 gig channels connects to the silicon switch inside of the UCS 6100. Therefore, each one is still fabric connected. So what you've actually done is extended the I/O input on the switching fabric in the 6100 down a 10 gig port to the back of the UCS chassis. Then what we do is we then pin, this is the syntax that Cisco uses, is then pin each of the blades to one of those 10 gig ports. The configuration of the FEX module is held within the 6100. So instead of the NIC actually having the intelligence to choose VLANs or VLAN tags, it actually gets pinned to an I/O channel, and the configuration of the NIC is determined by the neighboring switch. That is quite a different way to approach. So what you end up with is UCS blade 1 and UCS blade 5 being pinned to a given 10 gig channel, and the configuration of the NIC that's attached to that channel is then determined by the neighbouring switch. And that is, as I understand it, FEX.
Okay, so does FEX, however, give you the ability to effectively pin a VM to one of those to the fabric? Or is there still an upstream or downstream, according to what you're talking about, virtual switch involved?
So you can then attach a virtual switch to each. So the FEX stops at the physical layer. It doesn't affect the virtual system that goes on top. So the hardware is not aware of what VMware does, or Microsoft's Hyper-V, or bare metal Linux running on the top. What it does do, though, is instead of saying there's only one NIC in the chassis, and therefore the vSwitch connects to it, it pins the configuration of the virtual NICs. So this is where we get into some really interesting syntax between VMware.
NIC, in our terminology, be what the NIC for the VM.
That's right. So now at the moment, I'll try and make a context switch when I switch in and out. So when I talk about the UCS, and we have the physical NIC, that physical NIC can now be virtualized to a vNIC. I'm still in the UCS. That one physical NIC inside of the FEX is then presented to each blade in the chassis, which is then physically presented, appears as a pNIC in VMware. So I'm switching context to VMware. So now the FEX, the vNIC on the FEX is now pNIC in VMware. Okay. The only way that you can control the VMware today is to still use Nexus 1000V,
or use VM direct path and map a vNIC in the VM directly to the pNIC of the FEX.
That's correct. Of course, using VM direct path has certain hypothetical limitations. However, there is one significant benefit of using VM FEX, and that is you can now take the feature set of the VM FEX and say, I want to have just one pNIC, and I'll have an active and a standby NIC. So I'm shifting context again down into the UCS chassis. So I have a physical NIC which is pinned to a given channel up to the UCS 6100. I can declare the second VM FEX, or the second NIC in the chassis, to be standby. In the event that the upstream switch or channel or connectivity or the FEX fails, it automatically fails immediately, provided a feature called Fabric Sync is enabled in the UCS 600s to the alternate path. This removes the need of what many people do today for LACP or active standby NICs in VMware. What VMware sees, or what Hyper-V sees, or what Linux sees is just one NIC. But underneath that, at the physical layer, there's actually a failover path. That's a hitless failover in the event of some sort of upstream failure.
Okay.
Unfortunately, I've forgotten the name of that. It's got a fancy name. I'll see if I can find it.
So, in essence, VMFEX gets, so you're saying that LACP is not necessary, so link aggregation is no longer needed?
That's correct.
So so it does that. So in order to use effects, would I have to modify can I only use a Nexus 1000V? Can I use any other type of vSwitch? And if I do I have to put the port groups for those vSwitches in a different load balance mode?
So your VMware so normally what you would create with a VMFEX is you would create multiple mix. One would be, you would still use a standard vSwitch configuration for your vMotion and your vConsole interfaces. And then you would create an active standby VMFEX just for the failover path. Okay. Because in the event that the server fails, you still want to be able to get to its console, or you still want it to vMotion correctly. You don't use VMFEX for all the different NICs that you need. But you create the VIC slot, or the virtual interface card, and you declare it to be active standby. And so what VMware only sees for the data interface, or the data vSwitch, is one NIC, not two.
Okay.
The VMware sees one physical NIC. I'm shifting context to VMware, sees one pNIC. What you do with it inside of VMware is then up to you. But underneath the VMware pNIC is a VMware vNIC. Is a UCS FEX VNIC, and underneath that is either one of two physical NICs.
Right. So it's not actually quite the way it was described before, where it was actually extending the fabric all the way up through the virtual environment to the VM.
No, it's still doing that. So the silicon chip has an I/O channel that goes into it. That I/O channel extends down to the UCS 2108, and which then connects to the VMFEX on the blade. And so that data channel is still isolated from the time it reaches the VMware PNIC, reaches through the VIC, through the VMFEX, through the 5100, through the 2104 in the chassis, then up to the 6120. That whole pathway looks like a patch lead, right the way up to the 6100.
So is it just another way of encapsulating data?
No, what they actually do is you pin them all down. So the whole pathway is locked into place. It's using VN tag or... Yeah.
Hi, this is Michael. I want to jump in for a second because Ed said this is different than, I'll say different than the marketing, which implied pinning the data path all the way to the VM VNIC. And your clarification is this pins the path all the way to the E6+ PNIC.
Yep. Yes.
Okay.
So you're pinning the E6+ PNIC, which to a given port on the 6100.
Yes.
Okay.
And importantly, the configuration of the port is on the 6100 as well.
Okay, so I got a question on this. Now, let's say we have a simple example with 10 VMs. Now, and I would make 10 PNICs available. Each one would go to its own vSwitch, and each of the 10 vSwitches would get its own individual port group that would be assigned one per VM. Is that the way that works?
I'm a bit weak, a bit shabby on my VM syntax, but I think the answer is yes. What you will see, or what the network sees, is 10 individual I/O channels on the 6100s, on the UCS 6100s.
Okay, wait. So on the fabric extender, right, which is the FEX that's plugged into the UCS blade.
Yes.
I can configure 10 PNICs.
And put one, you could have 10 PNICs in to the hypervisor, so to VMware.
Okay, so ESX would think that it has 10 Ethernet ports.
Yes.
And each one of those Ethernet ports is configured by the upstream big core switch.
Yes, by the I/O module, or the 2104, as it's sometimes called in the chassis. So in the bottom of the chassis, there's the I/O module, which is then configured into FEX mode, and then it goes up to the 6120 above that, as I understand it.
So, okay, given that, Nate asked the question, is the FEX built into the UCS Palo or 2104, or is it some other new module that you have to buy, or is it just a firmware upgrade?
It's a new module. It's a new piece of hardware that supports I/O pinning and the FEX. So there's a new tagging feature in the used to be called VN tag, now it's called VMFEX. So VMFEX is synonymous with VN tag, although there's some notorious differences to do with the signaling between the FEX module and the 2100, and then down to the 6100.
Or, well, actually up, isn't it? It's usually the top of the rack.
Sorry, I'm looking at a diagram here and it's the other way around. So I was talking figuratively. So one of the interesting things to think about is that VMFEX from Cisco today is a pre-standard implementation of 802.1 QBG, which is a standard which we hope in time will define this as an open standard for everybody to use. And companies like Hewlett-Packard and so forth have announced that they'll support that when the final standards come out.
So it's a pinning technology so that I can use multiple I/O ports and effectively map those I/O ports to a given switch port.
Yes. So it's actually as if you're running, you can instantiate multiple physical NICs and present them to the hypervisor, and then as if you are cabling those back to the external switch.
You mentioned some limitations earlier. Can you go over those briefly? Like, what are they now, and are those changing in the future at all?
Well, I'm not a Cisco employee. I'm just a user, so I don't have any internal view as to what's going to change into the future.
Well, I would assume the limitation is to the number of these PNICs you can have per blade type of thing.
Yeah, it's a ridiculous number. It's like 128.
Yeah, no one's going to have more than 100, that many NICs. The thing is that even though it's pinning a channel, those channels are still going over the same wire.
Yes, they are still sharing the wire, but they're going down a dedicated pathway. So when you come to an audit phase, like a PCI audit, and you're saying my PCI data flows down this port on this switch to this point here, you have a defined pathway where that PNIC is separated. Unless someone puts a 10G device between you and the 6100, and they can, then it won't work. Then they can take all the data they want. Yeah, but it won't work at that point because the switch in the middle is well. There's two options you can do at that point. One is to enable. Let me think about that. There is a thing called MACsec or 802.1 AE, which allows you to do MAC level encryption if you buy the extra licenses. That's an intriguing feature. How much of an overhead is something like MACsec? There's in the Cisco. It's a Cisco proprietary feature today. There is theoretically a standard coming into the future, as I understand it, and it's hitless point-to-point encryption. So 802.1e or AE, or Cisco calls it MACsec, does hop-to-hop encryption between adjacent layer 2 Ethernet ports. It's done at layer 2. It's done at egress and ingress. The encryption is done at egress and ingress. It's still in its early phases, but that's what I would be looking to if that's a concern.
Sounds a lot like what we do in wireless networks, right? It'll be some variation of WPA or something.
No, it uses 802.1 AE. It's been around for a very long time.
Oh, in terms of the encryption protocol?
Yeah. It'll still be AES, or it'll be modular, like you say in Wi-Fi. Just choose whichever one you want. But at this point, it's bound in the silicon. I actually haven't looked at the details because it's not been a requirement. The data centers the one data center I'm building, which has this in it, doesn't require that because it's physically isolated and armored and things like that.
So this is interesting. Does the Nexus 1000V support MACsec?
No. It's software. It can't do encryption at that sort of rate.
Well, it can. The question is, given an AES and I encryption accelerator inside of the hypervisor, the overhead should be much, much, much lower.
At this point in time, I wouldn't believe it does. But as I said, I'm not in the current network I'm building. I'm choosing not to use Nexus 1000. It does change often, so it might do in the future. But my immediate response is that you can't run a 10 gigabit per second encryption without silicon and systems.
Oh, I think you're absolutely right, but Ed is implying because of the new chips from Intel and elsewhere where they are putting AES and other silicon directly. I mean, they are putting encryption directly into the Intel silicon. So potentially that could be leveraged by new software versions, and we expect that they will be.
So could the VMFX card do it? Then that would be a different discussion. We're not talking about Nexus 1000. You'd have to have an I/O channel then in the hypervisor down to the card to access the crypto features.
Yeah, I think that would be harder. It's actually because it's going to be part of it's because it's part of the NI, it's because it's part of the silicon of the Intel CPU, you could offload the encryption from, if you're trying to do encryption in virtual machines, or if you're trying to do encryption inside the E6 kernel, or you're doing encryption inside the 1000V, you could offload it to the crypto module on the Intel CPU. I think in the case of the FEX, since Cisco is already putting a crypto module into the FEX, there'd be no bonus, directly by leveraging the central processing unit to do it. It's probably better to still do that on the FEX.
I'm not saying that, just to be clear, I'm not saying that they are. I don't know if they are or they aren't, but it would make logical sense to say if I have a NIC and it's got X amount of horsepower, then I could enable a MaxX feature on there. Use the same chipset that they use in the switches to do the same thing. I don't know if Cisco is or isn't. I haven't got a view of that. I'm not at this time.
Right. And then anything you turn on like that will affect the other limits, right? The limit of 128 logical PNICs per FEX is also, that's a soft limit, right? That's some.
No, that's a hard limit.
Well, but that's a data structure on the card. How many 10 gig channels full duplex the card can do is going to be far less than 128, right? It's going to only do one 10 gig channel full duplex, correct?
No, the way the silicon works on a NIC card doesn't work that way at all. The limitation for 128 is probably around the maximum number of VN tags it can realistically hold in a memory buffer, but that's about it.
Well, no, that's the control channel limit, but you have a data channel limit as well, is what I'm trying to say. Right, so when you talk about channelizing to the 6100 and you have a 10 gig channel to the 6100, you can split that 10 gig channel at the ether layer, right, and channelize your Ethernet up to 128 times. But you don't then get 128 times 10 gig.
No, you still get
that
10
way.
gig. Yeah, you still get 10 gig
aggregate. Yeah, you get 10 gig. You get 10 gig aggregate no matter what. But you, as you're saying, is you can channelize it for basically, I would call a higher integrity separation of traffic than VLANs, but not as high as separate copper, right? I mean,
so operationally, you get some benefits because the FEX module is configured from the 6100. And
basically, you're saying the FEX can be configured by the 6100 per chassis. I mean, per rack, and then
per blade.
I thought the 6100 was on a rack. Was the top of rack switch?
It is the top of rack switch.
So I can configure from one 6100 all blades inside that chassis.
Yes. So when you switch the UCS 2100 into FEX mode for this port, then you're effectively extending the I/O channel all the way up to the VM FEX on the blade.
Okay.
So you're pinning the whole data path right the way down. So when your PCI auditor comes along, you can say, this VM FEX connects to this I/O port on the 2100. It comes out this uplink port and connects to this port on the 6120 or 6140.
But your data is still shared across a single cable. So you need to inspect your path, make sure that the data
by pinning your data to a specified path, only PCI compliant data flows that path.
But still on the same cable. You only have two cables coming out of the back of a UCS chassis, maybe four.
You can have up to 8.
Basically there for redundancy. So I'm still using one cable for as many paths I have. So that cable becomes the issue. The fact that's not the point of, as well as the switch it's connected to.
No, that's not the point of pinning. So the point of pinning is so that you could say that I have a VM FEX on blade 1. It's pinned to uplink port 1 on the 2100, which is pinned to port 1 on the 6120. Now you could choose to put no other data on that cable but a specified blade or a specified data flow. It's not shared. So you could choose not to share it. In the same way that when you plug a physical NIC into a classic 1RU server and you put 10 NIC cards into there, you can say that this is a dedicated channel. So what it's trying to emulate is a NIC in a 1RU, in a server. So in the old days, we used to have a HP server or an IBM server, and we'd put 10 1 gigabit NICs in it, and these were the two vMotion interfaces, and these were the two vConsole interfaces, and this was the two storage ports over to here, and this was the two data ports over to here. That is what you're emulating with the VMFEX. And that cable that then comes out the back, you can then pin to be on nominated. So there's no sharing between it and the switch at the top of the rack. There's no switching. There's no local switching.
Only one cable. You only have up to 4, right?
You can have up to 4 in the current UCS 5108 with the 2104 modules. In the next generation, it's up to 8.
So again, if I have 128 channels, I'm still going to be sharing them across a given wire.
Yes.
So
yes.
that
If you choose to implement VMFX and have 128 PNICs and present 128 PNICs to, if you create 128 FEX VNICs and present them as PNICs to the hypervisor, then sure, they're going to be shared from that point forward.
Well, they're going to be shared.
The only way you can get around that is to use ROCkey or InfiniBand, which does direct memory access from point to point, which then is arguably not sharing.
Well, still is. It's still the same cable. That's what I'm talking about.
But this extends it a lot further up the stack. So where in the past pinning was possible on the UCS 2100 inside the UCS 5100 chassis, you're now extending the pinning to the NIC in the blade.
And allowing it basically up till the hypervisor's physical NICs.
Yes.
Okay.
Now, what could I don't have any view of this. I don't have any pre-briefing, any information or any secrets. I would assume that in time, the Nexus 1000 would get new features to leverage FEX capabilities as well.
I would hope so.
Yeah.
So, Ethan had a question?
Well, I was just going to say that this sounds like a great solution for organizations that use their UCS chassis for other than just VMware. So if you want to run some Linux boxes bare metal and have them have different network ports, what have you, Nexus 1000B gives the network back to the network administrators only for VMware shops. But if this solution would give the network back to the network administrators for mixed shops that were doing VMware and other OSs on their UCS.
Correct. So the most common usage for it is indeed with bare metal Linux or for Hyper-V, because Hyper-V doesn't support multiple NICs. I'm not 100% sure of what that means. Somebody told me something about that Hyper-V has some quite stark limitations around the networking layer.
Well, Hyper-V presents what they call a layer 2 switch, and it's actually a bridge, from what I understand. Zen is sending KVM is actually the same way. They use a bridge, unless you're using the Open V switch. And as we know, bridges and layer 2 switching is quite a bit different.
Yeah.
Kind of look the same, but they're really, really, truly not.
This allows you to present one PNIC to the hypervisor,
exactly.
not two. So if you configure it one way, then you don't actually need the bridging function then, and you take away that challenge.
Mm-hmm.
Well, it's not like this would work with Hyper-V or Zen the same way, right? Because it's a spoof at the hardware layer, so to speak. The hypervisor has no idea that the FEX is doing this.
Exactly. So
I was also going to mention that there's been some leaks about the fall or winter release of Hyper-V, so I think we're going to see a better V-switch or something like a V-switch from Hyper-V at the end of the year.
Not saying anything.
Well, I'm not talking about any privileged information. I'm just talking about what I've read in the blogosphere.
Yes, I've read that same thing in the blogosphere. So talking about that, so basically VMFX doesn't really change our virtualization security stance at all, or even our cloud security stance. What it does do is possibly change our hardware security stance.
No, I think it also helps with the separation of duties, Edward. I think that's a good point that Eben was bringing up, is that there's a philosophical or cultural problem. I've seen it. I'm sure we've all seen it between the networking people and the virtualization people. And maybe this puts fuel on the fire, or maybe it puts the fire out. But it definitely does affect some change, certainly in the Cisco shops.
Well, and I'm seeing it still even more. I mean, people are saying that, I can't. I mean, what a lot of people don't realize, I guess, and I think it's a good thing to state here, is even with FEX or anything, a hypervisor is a multiple trust zone device. It is a mixed network, storage, and compute engine that contains within it minimally 5 different, at least 2 different trust zones, but most likely 5 default trust zones, and how you mix them is up to you.
Yeah.
If you're using it to its best efficiency, you are inherently implementing a cross-domain or multi-level secure infrastructure. That is absolutely right. That's
well, you got management, you have storage, you have vMotion, you have fault tolerance, and you have your regular VM workload, or VM workloads, depending on your trust zones there. So by default, there's 5 trust zones. If you think about all those being separate. Some people don't, some people do. How you mix and match is a security policy decision. In general, you would not want to mix and match those. So having, once more, in Blades the ability to pin and separately encrypt each channel would make them completely and 100% separate from each other would be a very nice approach.
There are solutions coming for that space. So if you look at companies like vCIDR, for example, who creates software for tunneling internally. At the moment, they only have it as a Linux driver, but I believe they're furiously developing for other platforms. And so you'd actually have a software NIC adapter which actually drives straight into a tunnel, and then you terminate that tunnel somewhere else on your network. At this point in time, though, they're still encapsulating it in IP, but there are some startups out there that are doing some interesting work in that space. So just keep an eye out for that.
Well, Nicira is out there. Isn't that the Diane Green startup?
Sorry, which one?
I think Diane Green's got a new startup, Nicira. They're in this space.
No, Nicira is doing...
the guy that actually wrote the distributed virtual switch for VMware went over there, too. It is Nicira, Diane Green, yeah.
So the Nicira thing, let me just double-check that they haven't gone left since I last spoke to him. Nicira is starting to look at a thing called OpenFlow.
Right.
OpenFlow is about directly programming the TCAM in the switching fabric so as to modify its forwarding behavior in a way that suits you from a device management perspective. So let me try and pitch OpenFlow in less than a few seconds to make sure you're not on the wrong track. When a packet comes into a switch, we have a table that we do a lookup. TCAM actually stands for Ternary Content Addressable Memory. It's a special type of memory status where you do one lookup, and in a fixed time frame, it'll give you a response no matter how big the table lookup is done. So it's a special type of silicon processor, if you will. It's not exactly that. That'll do. If we could program that TCAM to actually say data coming in on port 1 goes out port 10, but what if I say it's not only, at the moment we have spanning tree or fabric engines or pinning or all these, but mainly spanning tree, or in the future we'll have Trill or SPB, which define the forwarding path. And they would say that for a loop-free protocol, packets coming in on port 1 go out port 10. Packets coming in on port 2 also go out port 10. In the event that port 10 fails, it'll fail over to port 9, for example. OpenFlow is a group of technologies. It's not just one, but we'll stick with OpenFlow as one, which says, I have a software platform over in the corner, and Greg says, if a packet comes in on port 1 and it has a source IP address of this with a destination IP address, send it up port 9. And if a packet comes in on port 2 and it's HTTP with this destination, then send it out port 10. It allows me to override the forwarding table to some arbitrarily defined set of rules. So instead of using a 30-year-old model of a coherent set of switches exchanging a protocol to figure out a pathway through the network, we actually have a software platform somewhere that says, here's some rules that the network administrator made up, and then we derive that into some forwarding data, which we then program into every switch in the network, and they all know how to forward according to that. That's what Nicira is doing. That's different.
Well, if it's a soft switch that runs on a hypervisor platform, you can then do the necessary programming to make these sort of packet transmission destination decisions such that based on policy you can route them to from bastions as appropriate. So
that's correct.
So like when you said HTTP, then, okay, I've got this other place where I've got the best WAF in the universe, and anything that's got, that looks like HTTP, I'm going to run through my WAF, right? That kind of stuff.
It's not a security technology, it's a forwarding technology. It's a data technology.
Right, but it allows you to take a dynamic data center where VMs are moving around all the time and layer 2 is not static, and attach this forwarding technology to a VNIC. I mean, that's where I get interested, right? And then I can make sure that packets to and from virtual machines are forwarded to, a security bastion, right? Whether that's, me or one of my competitors, the point is that enables that technology.
Sure. You could pick up a given traffic flow. That's where the word flow comes from. So flow talks about the 6-tuple this source MAC, this destination MAC, this source IP, this destination IP, this source port, this destination port. That's basically what the TCAM can handle. It can get a bit more complicated than that, but let's stick with that for the time being. So you could theoretically implement that in a software switch as well as a hardware switch. In a hardware switch, the TCAM operates in a finite, time-bound situation. In a software switch, you could do it in a server. The challenge with doing software switching in a server is that the time when you need to have the CPU available to do soft switching is also the same time as you've got peak CPU load. So soft switching is not necessarily the panacea that Nicira wants you to believe. Nicira wants you to think that having a soft switch everywhere gives them unlimited amounts of flexibility. But at the very time that you suddenly start thumping a 10 gigabit per second data flow, and therefore your soft switch now needs to be working much harder than it was before, you're also going to have peak CPU time and also peak storage access time. So what you've actually just done is you've created a failure scenario by stacking CPU load on CPU load on CPU load, and actually going to throttle your virtualization platform into oblivion in a critical failure mode.
Well, you're making the assumption there that all your CPU is actually in use, and that's not necessarily the case in any virtualization environment I've ever seen.
No, my point is that
there's a number of concerns. You're right, but there just needs to design for that. It needs to be taken into account.
The point I was going to make is that there's an absolute limit, right? And I think you're pointing out there's very good reasons that we currently have dedicated devices to do certain things. And when you take a general purpose processor and you ask it to run the VM workload and you ask it to run the networking workload, you may be creating a problem for you.
That's correct. At the time of 100%.
But I do want to interject, right? Yeah. There's some smart folks out there, and if you go to like a Mendel talk at Stanford, we don't know where Moore's law is taking us. And it may be taking us in a direction where there's going to be plenty of cores in the motherboard, so to speak, or on the blade, the UCS blade. And some of those cores will do networking, and some of those cores will be doing processing. And these problems will not necessarily manifest. We'll be doing that.
So let's investigate that. So what would happen is your average utilization would have to drop way, way down. So what you would then have to do is to allow the peak load to transiently spike. You would actually have to drive your average utilization 30% lower than it is now to have enough overhead to burst into.
Again, not necessarily, because my average utilization for my network is maybe X. My average utilization for my CPU may be Y. Y may be sufficiently low that that's never a problem. But you don't know what Y is. Y is different for every workload. Is it 50%? Is it 70%? Is it 100%? Or is it just 3%?
You're talking in the positive mode, in the positive functional mode. Take the failure mode.
I'm taking the failure mode. I have more cores. Most people have, and currently in their environment, have more cores running on a given blade or CPU machine than they have VMs. I mean, come on. I may have workloads we're so over allocated, and then if I get 24 cores, I get 60 cores. I mean, there's a machine out there right now that has 64 cores. I'm never going to be running 64 VMs or even using half of those cores in some cases, and those people are only 20 to 1 compressed, consolidated.
Can I add another factor to consider is that there's a lot of the cloud providers is where Nicira is really targeting. They are going to have many, many hundreds or thousands of distributed machines. So on the average, there's going to be a lot of CPU capacity available. But what they don't have is they don't want to make a VLAN on the network switches on every rack for every customer. That would limit the amount of customers they could have, and it would also cause a configuration nightmare. So one of the security controls that is available through the Open vSwitch is the ability to create these tunnels. And most of the customers that a cloud provider has are kind of small. It would be like up to 100 servers or 200 servers per customer. And so you have thousands and thousands of customers. That's where it's a better fit. And
we already have technology that solves that today. That's not that was solved 10 years ago. That's the specious argument that Nicira is throwing out, and a lot of the OpenFlow people are saying, oh, you can't have enough VLANs. But we already solved that problem with Q and Q tagging, and we've already solved it with another technology called SPBB and SPBV, but SPBB is the one that you actually want in this case. The question is who's going to market themselves better. And at this point,
and is your current switching infrastructure going to support that?
Yeah.
Right? Aren't those proprietary or maybe more technical
Q&Q
protocols?
is not, but Q&Q is not supported with inside of the vSphere virtual environment at all.
Yeah, and the other thing is that
those packets get rejected outright. VMware supports Mac and Mac.
And not all the switch vendors support that technology either. If you're not using VMware, there's a lot of vendors that aren't using VMware for the cloud.
Exactly.
Yeah, so Q&Q is pretty widely supported amongst the LAN switches today. Only came out about 4 years ago, so it's still wandering its way through in the hardware architecture. SPBB requires no change to existing switches. It just depends on your choice of implementation around that. The question is whether software switching as defined by Nicira or whether alternative visions, maybe you would like to implement MPLS tagging in the vSwitch, which would be a more effective. I don't know why they don't do it. In fact, I don't know why VMware doesn't do a better job of networking overall. Why do we have so few features and so few choices? Mac in Mac is a dreadful decision. It's hyper insecure. It's vulnerable to any number of failure conditions to do with undirected unicast, multicast, or broadcast at an Ethernet layer. It breaks all sorts of capabilities. It would be much more efficient if Mac in IP. Having said that, VMware must be doing something in the networking space to make it better because they haven't done anything in the last 5 years of networking node or delivered much value to their customers there.
This has been a very, very interesting podcast. I'm loving it so far.
Well, no, actually, Mac and Mac weaknesses are actually very important to understand because vCloud Director and Lab Manager use Mac and Mac. So if they have unicast and broadcast weaknesses,
there's just too many acronyms going across right now. I'm going to have to personally go back and listen to this podcast and do some additional research.
Yeah, well,
glad I'm not the only one.
Mac actually, there is a Mac and Mac standard, 802.3 something or other, and I can't remember what it is, or 802.1 something or other actually. But Mac and Mac has, if it has broadcast weaknesses where you can actually see data from one tenant inside of another tenant, that would be extremely bad.
Well, I don't think it's just that. Anytime I hear something that sounds like Mac, I go back to my old ARP spoofing, ARP poisoning days, and I go, well, does that mean I can pretend to be a different Mac and I start seeing the traffic, or can I mess up the network with a Mac storm? I mean, I think what the point being made there is it's not, I'm going to guess, you can correct me, Mac and Mac works fine if everybody cooperates.
And worse, it's pretty rare these days, but remember the days when network adapters used to fail and then just send a packet with all ones in that MAC field because it was corrupted? That could take down an entire data center, one faulty NIC or one faulty cable where it's transmitting a false MAC, which is a broadcast. And a broadcast, so every host in that VLAN needs to receive that and process. It must rip the frame off the wire and process it. And inherently, switches must forward that data regardless of what you think. Potentially, software switching has some answers around that. But for today, Mac and Mac using vCloud is a disaster waiting to happen. It's just there are ways to get around it. Amazon gets around it with some fancy techniques, and some other people get around it. But vCloud is a weakness. It's a significant failure. The whole thing becomes a failure domain, and it's vulnerable to the most fundamental things, like simple things like Microsoft network load balancing will take down an entire VLAN inherently because it uses undirected unicasts, which effectively DDoSes every machine in the same VLAN. That's how Microsoft NLB works.
But have you actually done that, and has it failed in vCloud, or is it just a theory?
That's what happens today. So if you set up an Exchange server using Microsoft clustering, which is based around the undirected unicast, every packet that goes to the MAC address of the Exchange cluster gets sent to a phantom MAC address. And because the switches don't know where it is, it must flood that out every port in a VLAN. So let's say that there's 10,000 virtual hosts on 1,000 physical machines. Every one of those 10,000 hosts will receive that frame and have to pick it up off the network. Now let's assume in a big network that you've got the 1,000 physical hosts spread across, say, 20 physical switches, and let's say they're on two sides of the data center. That frame, just for one host right on the far right-hand side of the data center, then has to traverse your backbone to all of those 20 physical switches, to those 1,000 physical hosts, to those 10,000 guests.
Okay.
And that, you can't stop that, right? If somebody decides to deploy an application and you don't know that they're sending something to an unknown MAC address, bang, you're dead. It's one single failure to make.
And that's going to be done for every frame in the load balance, right? Every frame going to the Exchange server.
That's correct. So if your Exchange server is only handling a meg or two of traffic, we'll hardly know about it. But Exchange servers don't run at a meg or two. They run at 10 meg, 20 meg, 50 meg.
That begs the difference. If you imagine that VMware's implementation of Mac and Mac would actually understand that. And you're telling me you've actually run this test?
Yeah, it's common. It's the thing we deliberately design against in networks constantly. We try and put checks and balances, but inherently you can't filter it out. You can't even tell.
Okay.
Oh, OpenFlow 1.1 supports Q and Q. Nice.
It doesn't support Q and Q. Not ESX, not vSphere at all.
No, I was talking OpenFlow.
OpenFlow does.
Yeah. So in the last 15 minutes, we've got a lot of good information on VMFX. Now we understand how that actually works. I was a little confused myself. Thank you very much, Greg.
All right.
Talked about some of the other weaknesses inside of vCloud and the networking. We've got about 13 minutes left, so let's talk a little bit about this upcoming small show, VMworld.
Never heard of it.
Never heard of it. And what's going to be happening at that? What is everybody looking to get out of it? And Greg, I'm assuming you're going to hopefully be there, if not in Copenhagen, I imagine.
No, I'm not traveling this year. I only have 2 nominated events this year, and none of them are vendor things.
Okay.
Well, there's a lot of people on the East Coast who think they're traveling yet. Are you leaving early?
I actually arranged to come a day earlier, so I'm leaving on Saturday night.
Okay, you may make it then.
Yeah. So
I might see you guys there on Wednesday if I go at all.
Good. So
definitely look me up, even.
I'm assuming there's going to be a whole lot of virtualization security and cloud announcements at VMworld this year. Let's make some predictions based on what we know about what we're going to see. Michael, why don't you go first?
Me? Ed, I would say all the important announcements already happened.
The important announcements already happened. Yeah, I saw that. It's a very important. It's a very interesting announcement, and that is Catbird announced that they're OEMing vShield app.
Oh yeah.
It's a small announcement, but that's actually a very intriguing, interesting announcement from the perspective of the rest of the virtualization community and what it implies. And whether or not that's true is yet to be borne out by other such partnerships between the vShield folks in VMware and the rest of the ecosystem. But what drove that, Michael, if you could tell us?
Yeah, well, I don't want to turn this into a Catbird commercial, but what drove it was customers wanting a single policy decision point, but the ability to mix and match different controls.
Okay.
And this is just part of Catbird's overall strategy of integrating multiple controls underneath the hood, as we've already done with SourceFire and other technologies. And this allows us to make it simple for customers to add that virtual firewall control and then to manage it in a elastic, dynamic, policy-based way.
Okay. So that's one announcement that's coming out. There'll be more about that on the show floor. Everybody should go see the Catbird booth. HighTrust has some new stuff coming out. Go see them. Trend has some new stuff coming out. I know VMware does, of course.
I'm assuming Altor will be there with the Juniper banner, right? So they're
Juniper VGW. Their new name is Juniper VGW. Yes, Altor should be there with the Juniper banner.
Not to be confused with Cisco VSG.
Yes, Cisco VSG. What else? What else is up there? I mean, any new information? Anybody have anything new about about cloud computing they want to share?
I predict VMware will announce it's acquired one or two companies.
Gee, I think they already did. No?
I don't know. Do they announce acquisitions at the show? Have they done that before?
No, usually pre-announce those.
Yeah, those tend to happen when they happen because it's pretty unpredictable when acquisitions close.
Yeah. Greg, what do you think we're going to see from a networking perspective, or even from a networking security perspective?
At VMworld, probably nothing. VMware doesn't care about networking at this point in time. It's not part of their radar.
Well, I don't know, because considering that they have announced their vSphere 5 of several new networking technologies inside of their own stuff. In other words,
but it's interesting. He's kind of right. Remember last year Howie had that whole vChassis talk?
Yeah.
And
yeah.
Where did that go in the last 12 months?
So, in effect, at the moment, VMware is ignoring networking. My sort of view is, I'm not being negative about VMware. I'm just saying it's not on their radar this year.
Well,
my guess would be
not on their radar when they're doing IO resource pools specifically for networking. Give quality service throughout for egress from the hypervisor, which is actually new to vSphere 5.
Because storage is a bigger problem.
Well, yeah, so I was going to say, they already talked about that a couple of weeks ago with vSphere 5. I think it's pretty significant that they can take essentially the isolated hard drives on each system and turn them into a SAN.
Well, that's the storage VSA.
Storage pooling, right? Yeah.
No, that's the storage VSA.
Right.
So if you had to choose between storage being a limitation on growing VMware, networking growing on VMware, or memory or CPU or guest OSs being an arbitrary limit on growing VMware's penetration into the marketplace, storage is the problem. Storage is an industry that's about 20 years behind the rest of the industry. I mean, for example, look at this week. We had Pure Storage come out of stealth. Another SSD manufacturer come out of stealth mode and announced that they're producing multi-terabyte flash arrays with inline dedupe, zero block reclaim, compression, all the features that you pitch with a NetApp and a VMAT, an EMC storage array, and yet NetApp and EMC have had 3 to 5 years to develop flash products, and what have they given us? Nothing. They've just about delivered gigabyte-sized caching engines inside of their existing products. So VMware, I think, at the moment is investing their efforts in slapping the storage vendors around and saying, you guys need to do a better job. Let's try and take away all of that rubbish in EMC products around you've got to have this mystic API interface or NetApp with their NFS, and let's just abstract it down to some core functionality that'll work instead of saying it's got to be this and blessed with a unicorn horn that and taken out the back and had a priestly ritual with wizards to be blessed to go on the HCL that takes 3 years to go through.
Okay.
Well, when I read the Pure Storage, I'm thinking, well, why wouldn't Waffle work just fine on top of a flash array?
Yeah.
Right. I mean, shouldn't
Pure
matter.
Storage isn't the only one. What about Nimbus? What about all the other flash array? Violin, TMS, Samsung. All those people have got one of them as well.
Right. And, but then there's the virtualization memory startups that are out there too. I mean, that's another limitation. Whether you're talking about UCS blades or any blade, there's only so many gigabytes we cram on these things. Again, based on 20-year-old I/O memory architecture decisions.
Yeah. So, for example, I had a presentation from VMAX this week singing the praises of their 24 gigabit per second backplane. After 15 years of a 4 gigabit per second, no, 1 gigabit, was it 1 or 2? Anyway, like a couple of gigs inside of the backplane of their chassis. And yet Flash is going to flood that backplane way beyond that. I mean, we're talking about arrays today that do 1,000 or 10,000 IOPS. But these SSD arrays can automatically do like 100,000 IOPS before you even start doing fancy things with them.
Okay.
That's going to drive VMware adoption into a whole new space when the storage isn't the bottleneck.
Well, with that actually helps desktops and boot storms and things like that. So they've actually done a lot of work on that. The only thing there's a couple of new things in vSphere 5 for networking. Again, the concept of the I/O resource pools for networking. It's only geared for network to ensure some quality of service through the egress and ingress of the network across the vSwitch and across the most important VMs. Contention-based resource pooling is a very good step in the right direction. Is it the only step they could make? Probably not. But you can only put so much into everything. Right now, that's what they have there. What do you think about that, Greg, in the limited time we have?
I don't spend a lot of time working on VMware or focusing on it. It's just most of my work is around the networking and the security side, so VMware just looks like a packet generator to me. Okay. I'm not too bothered about how it works most of the time. When you're sitting on the desktop and you press the enter key, the flush has to go somewhere, and that's the VMware server as far as I can see. So.
Okay. Well, hopefully we'll see everybody at a VMworld, and as Michael said, it's a good place to make strategy and partnership announcements. It's also a good place to network and meet other people. I'd like to thank our special guest, Greg Farrell, for joining us and explaining VMFacts and the security around it. Thank you very much.
No problems. If you want to hear me rave on more, you could check out my podcast at Packet Pushers, of course, which is pure networking, so it's probably not that interesting. There you go.